Work. Okay. So here we are at the March CCL Health team meeting, and our illustrious guest speaker is Beth Malow. She actually has been a professor at Vanderbilt for a long time, and she's a professor of both neurology and pediatrics. She now lives in Vermont, but she's still on faculty at Vanderbilt. She's been in CCL a long time. She works with the Braver Angels, very involved with that. I think you were a co-founder or something. And she's been invited to do a talk at the national conference for the American Association of
Academy of Neurology.
Yeah,
Yeah.
which is super cool, next month. So we're her guinea pigs. And even though we're recording this, I'm not going to share the recording until after that talk because she's supposed to be giving a virgin talk next month. So yeah, so we look super forward to this. It's a great topic, and we can also maybe help her with any suggestions for next month. So take it away, Beth.
Thank you so much. Yeah, so just a little bit of background before I get started. We have a big plenary session with key talks in the conference, and I was asked to speak for 20 minutes on climate change and global brain health. It's a great honor. And I really appreciate you all being here tonight and listening because the more I practice, the better it gets. If you have any suggestions, I would welcome them at the end. I actually am not going to be taking formal Q&A during the talk I'm giving at the American Academy of Neurology meeting. However, what you tell me today can strengthen my talk. So I am greatly appreciative, and we will have the recording available. The AAN just asked that I didn't share it until after my talk. So we'll get it, Lori will get it out to you all after April 9th, I think it is, something like that. And it's global. We're supposed to really appeal, even though we're the American Academy of Neurology, we are a global international organization. So we were asked to make it global. So I'm going to try to do that too. Okay, so let me go ahead and get started. I'm just going to put on my clock, make sure I stay on time. This is the impact of climate change on global brain health. I work at Vanderbilt Medical Center. I have the luxury of working remotely from Vermont, which is a beautiful place. And I am, just go ahead and advance. Okay. What I want to do in the next 20 minutes is a lot. I want to talk about evidence for climate change because you never know when your neighbors or friends might have questions about it. The relationship of extreme heat and air pollution to global brain health, examples from wildfires as both a consequence of climate change and a culprit on health, the impact of not just air pollution, but other forms of climate like extreme heat on health, the very important area of hope. What can we do right now together to impact change in climate, and how can we work together? I want to acknowledge a very important group, which are my colleagues who are leading a group called Niche, Neurologists Interested in Climate and Health. And you'll hear more about them. Larry Junk, Ali Saad, and Brett Andrews have just been instrumental in this endeavor with me. And I'll tell you more about the website we put together and the quarterly meetings we hold. I also don't like to clutter my slides with a lot of references, so I made a QR code, and you can scan that and get to my references that I'm going to be talking about. Or you can just email me if that's easier. So let's start out with 2023 shattered records to become the hottest year on record since, since comparing to the Industrial Revolution. So starting, this slide shows starting in the 1940s, monthly global temperatures. And 2023 was the hottest year in this graph. And there's a correlation between heat and global CO2. And you can see this graph increasing since the 60s when the measurements were made by NOAA. Now we're at around 424 parts per million for CO2. It's actually curving upward, so it's an exponential, not a linear increase. And the reason we know what's going on with CO2 and we know that it's increasing over time is we can go all the way back 800,000 years to measurements. And I bring up this curve because people might ask you, what is the evidence for climate change? Haven't we been going through cycles for many, many years? And the answer is yes, we do cycle, right? There have been parts when it's hotter, there have been times that it's cooler, but this is not a cycle we're in right now. I mean, you can see here, we've never gotten in these cycles of warm and cold above 300 parts per million for CO2. And now look where we are. I mentioned we're 420, 424 parts per million. So this is unprecedented. And that's really important because people will hear in the news about cycles. And this is a very clear, evidence-based way to respond to them. And you might say, well, how do we know what happened 800,000 years ago? And the reason we know is because of these ice core samples. You can go to the poles of the Earth. You can acquire these ice core samples. And just like dating species or plants and animals, fossils, you can, just like rock and sediment layers, you can sample the ice in a similar way and see what the air bubbles trapped at different levels show you about the atmosphere's composition. So we're able to know what has happened over time. So I think this is really important just for you to know in case you speak with friends, colleagues, neighbors. Now, I mentioned 2023 being the hottest year on record, and actually it wasn't. That was because that slide was made in 2023. 2024 was actually the hottest year on record, and this is showing the global increases in temperature, and even areas that we normally think of as temperate, like Europe or Canada, they have a lot of red or pink, which is much warmer than average or record warmest in history. And, there's just not a lot of blue in here, which is cooler, right? Very, very little blue. And you might think, well, a lot of this is over the oceans, right? So does that really matter if it's over the oceans? And the answer is yes, because the heat over the oceans we know provides more energy for example, hurricanes to become worse and more intense. And we also know that the oceans absorb heat, and we can have glacier and ice sheet melting and then flooding. So this is really important, even over the oceans. It's global. And this is how the greenhouse effect works. You get your solar energy from the sun getting trapped by greenhouse gases emitted from fossil fuels, and they're trapping heat, and you have the effects of climate change. Now, it really is weird what's been happening with our weather. So, for example, when we think of hurricanes, we think of the Gulf Coast, we think of South Florida. We don't think of the mountains of North Carolina. But yes, this was the Asheville, North Carolina, the Hurricane Helene in September of last year. And many of you may have been to Lake Lure outside of Asheville. There was a beautiful flowering bridge, and you could see the destruction from that. But it's not just the US. Areas of Morocco, deserts that you wouldn't expect to be flooded were flooded in April of 2024. There was also flooding in southern Poland in 2024. Lots of flooding. And then wildfires is the other natural disaster that's been in the news a lot. Again, we know about the LA wildfires, but there were also fires in the Amazon in Africa, and there were fires in, this is in New Zealand, Australia area from fires out there. These wildfires are fueled by hotter temperatures. So climate change may not be increasing the total number of wildfires, but it may very well be making them more intense. And we know that wildfire smoke contributes to something called PM 2.5, which is a major toxin in air pollution. In fact, wildfire smoke is more of a contributor than fossil fuels. So let me show you the PM 2.5. So it's called PM 2.5 because it involves particulates that are tiny. They're less than 2.5 micrometers in size. And this is what they look like. They're pretty nasty. They've got toxins and metals and soot, all sorts of things. And they're very tiny. Here's a red blood cell, right? So compared to them, they're smaller. They end up in our lungs. They end up crossing the blood-brain barrier, getting into our blood vessels and causing stroke. In addition to wildfires, which are one of the major causes, vehicle exhaust, coal, other wood burning. And they're really the worst component of air pollution in relation to our health. They're responsible for more than 4 million deaths a year worldwide and lots of health consequences. And you might have heard of asthma and COPD, but they also cause heart disease and neurologic diseases, and I'll show you those in a moment. The mechanism of action is still being worked out, but people feel it may be related to neuroinflammation, oxidative stress, or epigenetic changes, which are changes in our genetics, DNA. And the impact of climate change and air pollution was the subject of a scoping review a couple of years ago. And the reason I highlight this, there have been many others since, is because it looked specifically at the air pollution, the PM 2.5. And also, my colleague Larry Junk and I wrote an editorial on this review that was the nidus for the neurologists interested in climate and health group that I mentioned, the niche group. I just wanted to mention one piece from this article. This is a Sankey diagram that shows interrelationships between different elements of air pollution and also neurologic disease. And I've been emphasizing PM 2.5, although there's ozone and other chemicals as well. But the PM 2.5, you can see it's very broad. I mean, you have cognitive decline, stroke, MS, even independent. We know that heat makes MS worse, multiple sclerosis exacerbations. Here, even PM 2.5 independently is resulting in MS relapse risk, stroke, TIA, dementia, migraines, Parkinson's. So it's quite broad. And just to hit on a few of these, stroke, I'll just mention that air pollution is believed to be one of the 10 modifiable risk factors attributed to stroke worldwide. And it's associated PM 2.5 with ischemic stroke in many countries, so it's global. Apart from PM 2.5, the extreme heat also contributes to stroke risk, mortality, disability, potentially through mechanisms like hypercoagulability, sympathetic activation, and inflammation. And dementia is also a big associated condition with air pollution. 3% of late onset dementia is felt to be due to air pollution. And the risk of dementia increases by 3% for every 1 microgram per meter cubed increase in exposure to PM 2.5. Like stroke, extreme heat also plays a role with increased hospitalization and mortality, felt to be either sleep disruption, dehydration, overheating, the effect of heat on medications. Medications can affect your ability to regulate heat. So all of these may be playing roles in making